can you solve this geometry challenge? Here's the question. Let's start with an isosceles right triangle. Now, using these three vertices, let's draw a segment inside of this right triangle. And these segments connecting each other, this is 3 units, this is 5 units, and this is 4 units. And this is x, the hypotenuse of this right triangle. Now the question, of course, is what is the value of this segment, x? Now pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. So given this figure, the goal is to find the length of this segment x. And on this video, I will show you 2 different solutions. So we have here the first one using the law of cosine. And the second one is using coordinate geometry. So now let's begin. So the first solution using the law of cosine. Alright, so to answer this question, using law of cosine, what we're going to do is to get a copy of this triangle like this. Now flip this over like this. Since it is an isosceles right triangle, if we connect these two, this is perfectly fit to one another. Now from here, we know this segment is 3 units, this is 4 units, and this is 5 units. And also, we created a right triangle right over here. If you connect these 2 points, we created a right triangle because we flipped this figure, right? Now, since this is an isosceles right triangle, this angle right over here must be equal to 45 degrees, and the hypotenuse simply equal to square root of 2 times the length of the side of this triangle, which is 3 times square root of 2. Now, let's call this angle be equal to theta. And now, we can now use what we call the law of cosine. Now, the law of cosine is a law in trigonometry, which is the square of the side of a plane triangle equals the sum of the squares of the remaining sides minus twice the product of those sides and the cosine of the angle between them. So using the law of cosine to this triangle, we can now get the value of this cosine theta. And using the law of cosine, we have 5 squared equals 4 squared plus 3 times square root of 2 squared minus 2 times 4 times 3 times square root of 2 times cosine theta. Now simplifying this, 5 squared is 25, 4 squared is 16, 3 times square root of 2 squared is 18, and 2 times 4 times 3 times square root of 2 is 24 times square root of 2. Now, simplifying this, oops, they are just the same thing. Simplifying this, we have here negative 9 equals negative 24 times square root of 2 times cosine theta. And divide both sides by negative 24 times square root of 2. This will give us 9 over 24 times square root of 2. 9 and 24 have a common factor of 3, so factor out 3, we have 3 over 8 times square root of 2. Now, rationalize, therefore cosine theta equals 3 times square root of 2 over 16. Therefore, cosine theta equals 3 times square root of 2 over 16. Now, we will use again this law of cosine to this triangle. And from here, what we're going to do is to let the length of the side of this isosceles right triangle be equal to y, since this is also y. Now, this x, since it is an isosceles right triangle, this x, we can rewrite this as y times square root of 2. So if we find the value of y, multiply it by the square root of 2, and we get the value of x. Now, the problem in using the law of cosine in this triangle, the angle is not theta at all. This is just theta plus 45 degrees. Therefore, to address this issue, we need to find first the sine of theta, and that is easy to find because using the Pythagorean identity, sine squared theta plus cosine squared theta equals 1, we can now solve for the value of sine theta using cosine squared theta. This is just square root of 1 minus cosine squared theta. This is positive because technically speaking, this theta right over here is less than 180 degrees. So sine of theta must be a positive number. So now, let's figure out the value of sine theta. Let's replace cosine theta given this value 3 times square root of 2 over 16. Now, squaring this, we have here 1 minus 18 over 256. And combining those numbers, we get sine theta equals square root of 119 over 256. Which is, when we simplify this further, we get sine theta equals square root of 238 all over 16. So now, we know cosine theta equals 3 times square root of 2 over 16, and sine theta equals square root of 238 over 16. So we will use those values to answer this question. Now, finally, we can now use the law of cosine in this triangle. So this will give us y squared equals 4 squared plus 3 squared minus 2 times 4 times 3 times cosine of 45 degrees plus theta, or theta plus 45 degrees. Now, simplifying this, we have y squared equals 25, which is 4 squared plus 3 squared, minus 24, 2 times 4 times 3, then cosine of theta plus 45 degrees. Now, we will use some identity to address this cosine of theta plus 45 degrees. This is simply equivalent to cosine theta times cosine 45 minus sine theta times sine 45 degrees. Now, from here, we know cosine 45 degrees and sine 45 degrees are both equal to square root of 2 over 2. So we can factor out square root of 2 over 2, and the rest is bring down. Now, this is cosine theta minus sine theta, and we know the values of cosine theta and sine theta. Here are those values. So we can replace cosine theta and sine theta respectively. Now, let's focus on this result. Now, from here, distribute the square root of 2 over 2 to 3 times square root of 2 over 16 minus square root of 238 over 16. And now, distribute this 24 to 3 over 16 minus square root of 119 over 16. Now, combine like terms. So, y squared equals 41 plus 3 times square root of 119 all over 2. Now, to get the value of y, let's get the square root on both sides. So, y equals square root of 41 plus 3 times square root of 19 over 2. Now, let's focus on this result. This is the value of y, but we don't want the value of y. We want the value of x. And we know x is just y times square root of 2. So, let's multiply square root of 2 on both sides. Now, this expression, we can say that this is equivalent to square root of 41 plus 3 times square root of 19 all over square root of 2. So we can cancel out square root of 2 in the numerator and the denominator. Therefore, y times square root of 2 simply equal to square root of 41 plus 3 times square root of 119. And y times square root of 2 simply equal to x. Therefore, using law of cosine, we get that x equals square root of 41 plus 3 times square root of 19. And this is our answer to this question. Now, how about without using any trigonometry or without using any sine and cosine? So let's have the second solution using coordinate geometry. So let's begin. This is a challenge to us of one of our followers, that if we can show a solution without using trigonometry. And here's my response. So first, let's put this right triangle, this isosceles right triangle, inside to the first quadrant of a Cartesian plane. Now, from here, let this point of intersection be equal to h comma k. And also, let y be the side of this isosceles right triangle. And from here, we will use equation of circles to answer this question, or to find the value of x. Alright, so first, let's draw a circle with a radius of 3 and the center at h comma k. So we only need one point to create the equation of the circle, and that point is this point, or simply equal to the origin. Therefore, the equation of this circle must be equal to h squared plus k squared equals 3 squared simply equal to 9. Now, let's have another circle with a radius of 4 with a center of h comma k, and now using this point with a coordinate of y comma 0. Therefore, the equation of this circle must be equal to y minus h raised to the power of 2 plus k squared equals 4 squared simply equal to 16. Now, let's have another circle, the last circle, with a radius of 5 centered at h comma k. And we need this point with the coordinate of 0, comma y. Therefore, the equation of this circle must be equal to h squared plus y minus k raised to the power of 2 equals 5 squared, simply equal to 25. Now, using these three equations, we will solve for the value of y. Alright, so we have three equations and three variables. Now, let's proceed to this third equation. And what we're going to do is to simplify. So we will do this very quick. Now, let's expand y minus k raised to the power of 2. This will give us y squared minus 2yk plus k squared. The rest are bring down. Now, we have here h squared plus k squared. And we know, using the first equation, h squared plus k squared equals 9. So the value of h squared plus k squared is simply equal to 9. Then, subtract 9 on both sides. Rearrange some terms a little bit. So y squared minus 16 equals to yk. Now, let's set aside this result. And then let's get the second equation, and we'll do the same thing. Let's expand this very quick. So y minus h raised to the power of 2, we have y squared plus 2yh plus h squared plus k squared equals 16. Now, we know also h squared plus k squared is equal to 9. Then, subtract 9 on both sides. Rearrange some terms a little bit. So, we have y squared minus 7 equals to yh. Now, using these two results, what we're going to do is to square on both sides. If we do that, we get something like this. And 2yh raised to the power of 2, this is simply equal to 4y squared times h squared. Also, 2yk raised to the power of 2, this is just 4y squared k squared. And now, to eliminate h squared and k squared, what we're going to do is to add these two results, like this. Now, since we have a common factor of 4y squared, if we factor out 4y squared, we have 4y squared multiplied by h squared plus k squared, which is, we know the value is equal to 9. By the way, the rest is bring down. So we can replace this with 9. Now, 4y squared times 9 simply equal to 36y squared. Now, focus on this equation because this equation contains only the variable y. So we can now find the value of y. Now, let's expand this very quick. So y squared minus 16 raised to the power of 2. This will give us y to the fourth power minus 32y squared plus 256. Expand y squared minus 7 raised to the power of 2. We have y to the fourth power minus 14y squared plus 49. Then bring down 36y squared. Now, combining like terms, we get 2y raised to the fourth power minus 82y squared plus 305 equals 0. Now, to find the value of y, we can say that this equation is a quadratic equation in terms of y squared because y raised to the fourth power simply equal to y squared raised to the power of 2. So we can use the quadratic formula to find the y squared. So y squared equals negative b plus or minus square root of b squared minus 4ac all over 2a. Performing the quadratic formula, this will give us negative of negative 82 plus or minus square root of negative 82 squared minus 4 times 2 times 305 all over 2 times 2. And simplifying this, we have y squared equals 41 plus or minus 3 times square root of 119 all over 2. This is the value of y squared. We want the value of y. Now, let's focus on this result. And to determine the value of y or the proper value of y in this question, what we're going to do is to use the triangle inequality. Now, using triangle inequality, we can say that y is between 2 and 7. But technically speaking, the side of this isosceles right triangle must be greater than 3. So, the value that we need for y is definitely greater than 3. Now, if we get the square root of 41 minus 3 times square root of 119 over 2, the value of y is close to 2 or 2 point something. So, 2 is too short for the side of this isosceles right triangle. Therefore, the permissible value of y in this question simply equal to 41 plus 3 times square root of 19 all over 2, which is the value of y, square root of 41 plus 3 times square root of 119 over 2. And we know, if we multiply both sides by square root of 2, because this x is simply equivalent to y times square root of 2. And if we multiply both sides by square root of 2, we get the result. Square root of 41 plus 3 times square root of 19. Therefore, without using any sine and cosine, we arrive at this answer, square root of 41 plus 3 times square root of 19. And this is our answer to this question. Therefore, given this figure, using two methods, law of cosine and coordinate geometry, we get that the value of x, the segment x, equals square root of 41 plus 3 times square root of 19. And as always, we are done.